Hey everyone, Jeremy Blum here with my 9th Arduino tutorial sponsored by Element 14. This week's going to be all about wireless communications. We'll be using 2 Arduino Unos, 2 XB radios, and 2 XB radio shields to have the 2 Arduinos communicate with each other. I'll walk you through the process of programming the XB radios, getting them on the right channel to talk to each other, and then we'll end up with a project where we hook up a potentiometer to one Arduino and have it turn a motor connected to another Arduino all wirelessly. So let's take a look at the parts for today and get started. Here's what we'll be working with today. Here I have 2 Arduino Unos, 2 XB shields for the Arduino, and 2 XB transceivers. The transceivers don't have to be exactly the same model. You can see that they're a little bit different here. That's just fine. I also have this SparkFun USB to XB adapter. This will allow us to program the XBs through a serial interface on the computer very easily. You don't have to use this though. If you don't have one of these, although I recommend that you get one, you can also plug the XB into the XB shield and mount the shield onto the Arduino Uno, and then program it through the Arduino Uno's programming interface. However, to get that to work and make sure you're not actually programming the Arduino and that you're programming the XB, you'll have to move these 2 jumpers on the XB shield from the right to left position, and you'll have to physically remove the Atmega microcontroller from the Arduino Uno. This is to ensure that all the serial communication goes between the computer's USB port and the XB radio. That's why I recommend using this. It makes the whole process quite a bit easier. I'm going to use this special breakout board from sparkfun.com to program our XBs. Each XB has to have assigned to it a unique ID, information about the other XB that it will be talking to, and a special PAN ID. PAN stands for Personal Area Network. All the XBs that are communicating with each other have to be on the same personal area network. So we have to program those 3 numbers into the XB so that we can get it working with our Arduino. Start by putting the XB onto the SparkFun shield. Make sure you put it on in the right direction, otherwise you could damage it. There's an outline on the shield that shows you the direction in which it goes in. Then plug it into your computer via a mini B USB cable. It should light up. Now let's go to the computer and get it programmed. You'll need a terminal program if you're going to connect to the XB module and set it up. I like to use PuTTY on Windows 7, but if you're using Windows XP you can use HyperTerminal, and if you're using Mac or Linux you can just Google for a terminal program and basically use anything. But if you want to use PuTTY, just type in PuTTY on Google and go to the download page, and you can just download the putty.exe here. The next thing you're going to need to do is figure out what COM port, if you're on Windows, your XB wireless module is connected to. Same thing goes for Linux or Mac, but it won't be called a COM port, it'll be called some other thing that you'll need to enter into your serial program so you can identify where you're communicating with. To do that in Windows, you go to My Computer, click on Properties, go to Device Manager, and if you go down to COM ports, you can see that we're using USB serial port 4. It'll be called USB serial port. So we're on COM 4, and we need to know that for using PuTTY. So let's launch PuTTY, and we'll choose serial, put in COM 4, and go to terminal and make sure you force on local echoes. Then go back to session and hit open. Okay, we're now connected to our XB wireless module. Now we're going to program the XB module. First you enter programming mode by typing 3 plus signs in succession. Then I'll go through and type in 3 commands that set the ID of the module it's going to communicate with, and the personal area network ID, so that we can set them all up. Follow along with me as I do this. You have to go faster at times out. In the event that yours times out and you don't get an OK after entering something, just enter the 3 plus signs and start again. Let's get started. Type in +++, wait for the OK. Then type in ATMY 1000. That sets the ID to 1000. You should get an OK at the beginning. Then type ATDL 1001. Hit enter. You'll get another OK. That's been written. The last thing we're going to do is set the PAN ID. Type in ATID 1111, then a comma. You'll get an OK at the end. Then type in WR and hit enter. That will turn into an OK. The WR writes the values to it permanently, so that even after it loses power, it still has that data stored inside of it. Okay, perfect. Now unplug that one, plug in the next one, and we'll program that as well. Okay, I've been sure to unplug the USB first to remove power, and then I changed the XB modules. PuTTY will now say that it's inactive because it lost connection over USB. We'll restart the session by right-clicking in the title bar and hitting Restart Session. This will reconnect it and bring us to a new line. We're now ready to start programming the second module. We'll follow very similar steps. Again, hit 3 plus signs to enter programming mode. Wait for an OK. Then type in ATMY 1001. This one will have ID of 1001. Hit enter, and you should get another OK. Then type in ATDL 1000. This is the ID of the one we just programmed. Hit enter, and you get another OK. Lastly, we'll set it to the same pan ID. ATID 1111, comma, you'll get an OK, and then type in WR and hit enter. And it's written. Okay, both of our XBs are set up to communicate with each other now. We can close this window and start playing with them. Now we need to write a program for each Arduino. We'll have the first Arduino read in information from a potentiometer and send it over serial. That serial will actually be transmitted into the wireless signal that's created by the XBs. The XB on the other Arduino will receive it and then use it to turn a servo motor. Let's write the programs for each of these first. I'm starting off with the program that we wrote in tutorial number 6 that read in the information from a potentiometer and put it over serial. This is already most of the way there. I'm only going to change one thing. Here, instead of transmitting a data value from 0 to 255, I'm going to transmit a data value from 0 to 9. This will just make our lives a little bit easier, as it means we'll only have to transmit one byte of data, and we won't have to worry about too much processing on the other end. This will allow us to turn the motor to 9 independent positions, which can be very useful for controlling things like a robotic arm, for example. So save that one, and now let's go open up another program that we'll use to control the motor. Now I have open the servo control program that we wrote in tutorial number 5. We're just going to make a few modifications of this so that it turns based on serial input instead of input from an infrared sensor, which is what we had originally written it for. Remember, you can download this from my website. So first off, we don't need the distance pin anymore because there's no more infrared. The rest of this still looks good. In the setup, we're obviously going to have to add a serial initialization because we're going to be reading in serial data. Remember, the XBs are actually communicating basically over serial data, except it's happening wirelessly. So we're going to read in serial data that's going to come over the XB modules. Okay, good. Now down here, we can get rid of our distance sensor. And let's read in our serial value. So the first thing we're going to do, like we've done before with serial, is we're going to wait until we actually have a value. Serial.available, and we're going to set that equal to 0. Okay, so this is an infinite loop, and it's just going to stay here until it has something available on the serial line coming into it from the other XB. Now, let's read in the data. So we'll use the same trick we did before, and this is why I decided to just make it 0 to 9. It'll make our lives a little bit easier. We'll do int data equals serial.read minus the char 0. And if you remember from before, this is converting the byte or char value that comes in into an integer, because this is the decimal representation of the number 0, and it will convert it into an integer for us, which is exactly what we want. So now we'll have an integer data that ranges from 0 to 9 based on a value that we just got. Okay. Now we're going to write a new variable called position that maps that to a value from 0 to 180 because the servo turns from 0 to 180. So we're going to map data from 0 to 9 to 0 to 180. Just like that. And just to be safe, I always put a constrain function after my map functions, just in case you get some erroneous data coming in for whatever reason. So we'll do position 0, 180. This just makes sure that no matter what, our values are always between 0 and 180. Otherwise, the servo will freak out and do weird stuff. Okay, now we actually want to turn the servo. So let's get rid of this. We have the function for turning the servo right here. If you want, you can put in a line here to print to the screen and see the values coming over, but that's not necessary. What is very important, though, is putting in a serial.flush. And what this will make sure happens is that any extra data that came in between when it read this, because remember, it's only going to read one character with serial.read. It's just going to read one character. So if 18 characters came in over this time period, we only want to read the one that we care about and then flush the rest of the buffer out. Otherwise, this servo is going to be flying all over the place and it's not going to know what to do with itself. So this is very important. And that should do it. So save this. And now download each of these to your Arduinos before you attach the XB shields. I now have both Arduinos plugged into the computer with no shields attached, via USB. However, I have no idea which one is on which COM port. If I have both of the programs open, I can go to Tools, Serial Port, and see if there's something on COM 3 and something on COM 5. So I'll hook this one up to COM 3 and this one up to COM 5. Make sure they're the two different COM ports. And I'll program the pot Arduino first. So this is the one that's going to accept the input from the potentiometer. And while I'm doing that, I'll look to see which LED blinks, so I know which one to hook up to the potentiometer. So let's hit upload. Okay, and you can see the LEDs on this guy blinked. So this guy is our potentiometer board. Now I'll upload the other sketch to COM 5. And we can see that the LEDs are blinking there. Okay, perfect. So this is the one that we're going to hook up to our motor. Let's get those wired up first. Okay, I finished wiring everything up now, and I plugged the USB back into both. Always make sure you unplug the USB when you're setting these up. On the potentiometer side, I have an XB shield mounted on top of the Arduino Uno with the XB that we programmed for the pot in that socket. The pot is hooked up with ground to ground, as you would expect. Green goes to the analog input 0, which actually goes up through the pin into the XB shield and can be plugged in right above where it ordinarily gets plugged in. All these pins here are broken out so that you can continue to use them. The 5-volt one, however, gets covered up by the XB module. That's no problem. Just plug in a wire underneath it with this green one right here, and then run that one to the pot. On the motor side, we do a similar kind of thing. We run a wire underneath it before we put the shield on so that we can get it into place. It kind of gets squished down by the shield, that's fine. That 5 volts goes to the motor, ground gets connected to ground on the Arduino over on this side, and then this one gets connected to pin 9, which we do PWM servo output on to control the servo. When you're all done with that, plug the two USB ports back in, as I did. Now let's see if this actually works. If we grab the pot here and give it a twist, perfect. The servo turns exactly 9 different clicks, which is precisely what we wanted. You can use this for a lot of things. You can use it to make a clock, all kinds of stuff, although you'd obviously have to send it more resolution. But I can turn it, and the servo turns just as we would expect it to. Now keep in mind, the only thing USB is doing here is providing power. There's no communication happening between these other than the communication between this XB and this XB. You could just as easily plug one of these into a 9-volt battery and power it like that. I just want to make one more quick note on programming the Arduino when you have an XB shield attached. Remember before I did it before I attached the shield. There's a good reason for that. XB hijacks the transmission and receive lines that the Arduino uses for programming so they can use it to transmit data. That's fine, but if you want to program the Arduino while the XB shield is plugged in, you'll have to reset both of these jumpers. In other words, take the jumper off of the pins and move it to the 2 outermost pins on both jumpers. That will allow you to program it via USB. But then, once you have the program on, don't forget to switch the jumpers back so that wireless communication works as it should. Thanks for watching this episode of my Arduino tutorial series. I hope you guys enjoyed it. As always, if you have any questions or something's not working right, feel free to post a comment on YouTube, on Element 14, or on my blog, and I'll have the source code available online as well. If you're having trouble with the XBs, you're not alone. It can be very difficult and frustrating to get them to work sometimes. The first course of action I'd suggest you take is to Google the problem. Chances are someone's had the exact same thing happen to them. That's usually what I do when I'm having problems with them. Otherwise, get in touch with me and I can try to help you out with it. Alright, until next time, thanks for watching. Thanks to Element 14 for helping me to sponsor this video series. They were kind enough to provide a lot of the materials that I'll be using to create these tutorials. Feel free to go visit their website at element14.com. Check out their community, which is a great place to talk to people about electronics, the Arduino, and basically anything else engineering related. And they also have a store where you can buy a lot of the parts that we'll be using in these videos.